Okay, the first thing that you want to do when you come to these example problems is read through the example problem and underline the information that's given to you. So for instance, I was given 20 mils of 0.2 molar nitric acid, and that was neutralized by 45 milliliters of sodium hydroxide. And I'm looking for the concentration of sodium hydroxide. Next thing I like to do is go into my balanced chemical equation and write that information underneath the substance that it goes with. So for instance, again, 20 mils of that nitric acid, and it's also 0.2 molar. And I'm given 45 milliliters of sodium hydroxide, and I'm looking for the molarity of sodium hydroxide. Okay, once you have that information in your equation, you can go ahead and start solving the problem. So your first step, let's say step 1, you want to go ahead and you want to find moles. So I'll put on there, find moles. You're going to do this with the nitric acid. You're using the nitric acid because that's what you have the most information about. So I'm going to use the molarity equation, so molarity equals moles over liters for the nitric acid. So I know the molarity is 0.200. Moles is what I'm looking for, and then 20 milliliters is 0.02 liters. So you're going to solve that, and you're going to solve that for moles. So you should be getting X equals 0.004 moles, and again that is of our nitric acid. Alright, so that's step 1. Step 2 is what we call the ratio step. So what you're going to do is you're going to use the mole ratios from your balanced equation and plug it in to figure out moles of sodium hydroxide. Now, when you're looking at your balanced equation, you get your mole ratios from the coefficients from your balanced equation. So if I look, there's no number in front of nitric acid and sodium hydroxide, so we know there's really a 1 there. So I'm going to start with that 0.0040 moles of nitric acid, and I'm going to plug that into my train tracks. So if I look up in my balanced chemical equation, there's no coefficient in front of nitric acid, so I know that's really a 1. I'm putting nitric acid on the bottom to cancel out my moles of nitric acid. So from my balanced equation, for every 1 mole of nitric acid I have 1 mole of sodium hydroxide. And then you're going to solve that. So I know it's 0.00400 moles. Now I have it of sodium hydroxide. Alright, our last step, step 3, is going to be to find whatever the question is asking for. So find what is asked. So in this question, I'm looking for the concentration of sodium hydroxide. So I'm going to again be using that molarity equation. So refer back to the molarity equation right at the top. And my molarity, which is what I'm looking for, is equal to moles, which is that 0.00400, divided by liters. Now I was given 45 milliliters of sodium hydroxide, so I have to change my milliliters to liters, which is 0.0450 liters. Solve that equation for my molarity, and you should be getting, with the correct number of sig figs, 0.0889 molar sodium hydroxide.